Good morning to all. Good morning. Okay. Today we are going to discuss about that, a new lesson. That is about the solid state. Lesson number 6. The solid state. Here, what is the learning objectives? Today what we are going to learn. That is, what are the general characteristics of solids? And what are the classifications of solid? And about what are the differences between amorphous solid and crystalline solid? Okay, these are the important questions we are going to discuss. So we have about the introduction about the solid. Here the matter can exist 3 different states. Then all of you know that. What are they? Solid, liquid and gas. Here, the solid is different from liquid and gas. What's the reason? Because the solids are possessing a definite shape and also having definite volume. And also, in the solid, here the atoms or molecules or ion may be tightly closed or tightly packed, held in certain arrangement. The crystals, we are saying the crystals like that, example sodium chloride. Anyhow, there are many types of solid, we know that. For example, diamond, metal, plastics. These are all certain examples of solid. Let us discuss about that. What are the general characteristics of solid? A very important question for the 3 mark question. I think that only 3 or 4 points is enough. Only 3 or 4 points. Okay. What are the general characteristics of solid? Solid have a definite shape and also having definite volume. Okay. What is the first point? Solid have a definite volume and also having a definite shape. The solid have an rigid. Solids are rigid and also are incompressible. Okay, incompressible. What is the first point? Solid have a definite volume and also having definite shape. That's the first point. What is about the second point? Solids are rigid and also it is an incompressible. Incompressible. And also having, one of the third point, solid have a strong cohesive force. One of the strong cohesive force. The fourth point is the solid have a short interatomic distance and also having molecular distance. Okay, solid have a short interatomic distance and also having molecular distance. Can we learn the 4 points? What are the 4 points? What is about the first point? Solid have a definite volume and also having definite shape. First point. What is about the second point? Solids are rigid and also incompressible. Incompressible. Okay. What is about the third point? Solid have a strong cohesive force. What's about the fourth point? Solid have a strong, short interatomic distance and also molecular distance. And that's one of the few points. One of the points. Their constituent, the solid constituents such as ions, molecules, ions, have a fixed position. Let us discuss about what are the classifications of solid. The solid can be classified into 2 types. One is a crystalline solid and another is amorphous solid. The crystalline solids are classified into 5 types. The ionic solid, covalent solid, metallic solid, molecular solid and also atomic solid. Here the amorphous solid we are saying plastic, rubber, glasses, etc. What are the examples of ionic solid? Means potassium chloride, sodium chloride. These are all the examples of ionic solid. Next about the covalent solid, there is a diamond. These are all what? Covalent solid. Next about the molecular solid, we are giving anthracene, phenanthracene, glucose. These are all the examples of molecular solid. Metallic solid means all metals. All metals we are giving the examples of metallic solid. And about the atomic solid means the frozen element like group number 18. These are all the examples of about the atomic solid. Let us discuss about that. What are the differences between crystalline solid and also about the amorphous solid? It's a very, very important question for the 5 mark question. It's a compulsory sure question. Differences between crystalline and amorphous solid. Please all of you take the book. We should be learn and write the question. Very, very important question. Let us discuss about that. What are the differences between crystalline and amorphous solid? Here, the crystalline solid. The crystalline solid, they are long-range orderly arrangement of the constituent. They are long-range orderly arrangement. Ordered, the molecules, atoms or molecules or ions are arranged in certain order. Orderly arrangement, okay, of constituent. What about the amorphous solid? They are short-range, randomly arrangement, randomly arrangement, as like honeybee are fly as a random question, am I right? Short range, amorphous of short range, randomly arrangement of their constituent. About the crystalline solid, the crystalline solid have a definite shape, have some shape, definite shape. What about the amorphous solid? It has the irregular shape. Irregular. It is have a definite shape. It has a irregular shape. And about the crystalline solid, generally crystalline solid are anisotropic in nature. Anisotropic. Crystalline solids are anisotropic in nature. What is about the anisotropic means? The property which depends on the direction of measurement. Okay? One of the property, anisotropic is one of the property which depends on the direction of measurement. That is called what? Anisotropic. They are about the isotropic. Amorphous is an isotropic. Iso means uniformity in all direction. Uniformity. Iso means what? One of the uniformity, same, uniformity in all direction. Then about the crystalline solid, they are all true solid. It means they are all pseudo solid, otherwise called supercooled liquid. Okay? This is about the fourth point. What is about the crystalline solid? Fifth point. It has a definite heat of fusion. Here have no definite heat of fusion. Heat of fusion is not definite. Okay? And about here, they have a sharp melting point. Here, gradually soften over a range of temperature and so cannot be molded. So can be molded. Here, they are gradually softened over a range of temperature and so can be molded. Here the examples we can say about the diamond, sodium chloride, etc. Here we can say the examples of plastic, glass, rubber, etc. Okay? These are about the 5-mark question. What are the differences between crystalline and amorphous solid? And we can discuss about that. What are isotropic and what are anisotropic? Okay? Isotropic solid and also anisotropic solid. Here the isotropic means uniformity. Okay, uniformity in all directions. For example, in solid state, isotropic we have the identical values of physical properties such as refractive index, electrical conductivity, etc. All in all directions. Okay, there is example about the isotropic. What is about the anisotropic? That properties depends upon the direct measurement. We can be say they show different value of physical properties. Okay, different values of physical properties when measured along different direction. We can be say about that anisotropic means different direction. Isotropic means uniformity in all directions. Okay. Next about the one of the very important question. What are the classifications of crystalline solid? What are the classifications of crystalline solid? Okay. Here the first one is about that already previously I discussed that one. About the first one is ionic solid. First the question is classification. classification of crystalline solid. So one is a ionic solid. Ionic solid. Second one is covalent solid. Third one is molecular solid. Fourth one is metallic solid. And fifth one is atomic solid. Here next one. Here, what is about the ionic solid? Ionic solid means the structural unit of ionic solids are cation and anion. Cation and anion. Examples of we can be says sodium chloride, potassium chloride, so all ions. For example, potassium chloride means K plus potassium chloride means K plus Cl minus. Am I right? Potassium ions. Sodium chloride Na plus Cl minus. Potassium, sodium. These are all ions. You can say ionic solid. Here the structural units of ionic solids are cation and what? Anion. They are bound together by strong electrostatic force of attraction. They are bound by a strong electrostatic force of attraction. Okay. To maximize the attractive force of cation is surrounded by an anion. What of the cation? For example, this is one of the cation is surrounded by anion. Surrounded by anion. Okay. Cation is surrounded by anion. Anyhow, here one of the very good example is about the sodium chloride. One of the very good example. We should draw the structure. How can we draw the molecular arrangement of sodium chloride? Molecular arrangement. That means you should draw the cubic structure. Okay. Suppose here sodium. Here sodium ion is occupied here. Next one is the chlorine ion. Okay. Next one sodium. Okay. Suppose here chlorine ion. Here also chlorine ion. In between chlorine ion, sodium. Here chloride. Chloride ion, chloride ion. Okay. In the between sodium ion, sodium. Here chloride, chloride. Sodium, sodium. Here chloride. Here sodium, chloride. Okay. Anyhow, you should try to draw the structure. What is about the ionic solid? Here, the structural unit of ionic crystals are cation and the anion. Cation and the anion. Okay, cation and anion. About here, what is about that? They are bound together by strong electrostatic force of attraction. Which force? Electrostatic attractive force. To maximize the attractive force, one of the cation is surrounded by anion. One of the cation is surrounded by anion. Okay. Here, the ionic crystals possess a definite crystal structure. Maybe it may be the solids are cubic close packed. For example, the arrangement of this is an arrangement of sodium and chloride ions in NaCl crystals. Next, what is about the important question is what is about the characteristics of this ionic solid? It's a very important. What are the characteristics? All characteristics are very important. Okay, all characteristics you should be learned. It's a 2 mark or 3 mark question. First one. What are the characteristics of ionic crystals? First one, they have high melting point. High melting point. And also do not conduct electricity. Okay, that is in the don't forget that these solids are do not conduct electricity. Okay, what is the first point? They have high melting point. What are the characteristics of ionic crystals? It's a very important question. Very important question. The ionic crystals have high melting point. The ionic crystals have, otherwise ionic solid have high melting point. These solids do not conduct electricity. Because, what's the reason? Because the ions are fixed in their lactic positions. If the ions are moving, it can be conduct electricity. Okay. Suppose the ions are moving, that is only in dissolved state, otherwise called in solution. In solution or molten state, in solution, the ionic crystals can conduct electricity. But in the solid, here these solids do not conduct electricity. What's the reason? Because the ions are fixed in their lactic position. Okay. The third point, it can do electricity. They can conduct electricity. When in their fused state or infused state or dissolved state, okay, they can conduct electricity in molten state when dissolved in water. Now the ions are free to move here in molten state. Otherwise, in solution, the ions are free to move. What is about the first point? What are the characteristics of ionic crystals are very, very important question. The ionic solid have high melting point. What's the second point? These solids do not conduct electricity. Then in the fixed, because the ions are fixed in their lactic position. The ions are fixed in the lactic position. It cannot conduct electricity. Suppose the ions are in solution, in solids, in the molten state, or in the fused state, or in the solution, the ions can conduct electricity. Okay? They are hard. And only strong external force can change the relative position of ions. They are hard. The characteristics, they are hard. Okay, these are the important points. At least you should learn a 3 point for the 3 mark question. Okay, 3 point is enough. Okay. Anyhow, what is about the first point? Ionic solid have high melting point. This is the first point. What is about the second point?
they are solid. These solids do not conduct electricity. Because the reason what? Because ions are fixed in their lattice position. What's about the third point? They do conduct electricity. In molten state, when dissolved or when dissolved in water, these ionic solids are dissolved in water. Now the ions can free to move. Okay, in the molten state or solution. In this state, it can be easily conduct electricity. And also, they are very hard. These ionic crystals are hard, as only strong external force can change the relative positions of ions. Can be changed the relative position of ions. Next we can discuss about that. What are covalent solid? Already I told you about that. What is the examples of covalent solid? There is a diamond and also silica. They are giving the silica and also silicon carbide, etc. These are all what? Covalent solid example. Next one is covalent solid. Here, the covalent solid, the constituent means atoms. Atoms are bound together in three-dimensional network. Okay, three-dimensional, maybe X, Y, and Z direction. Three-dimensional network. Okay, here the examples are, what are the examples? Diamond, silicon carbide, SiC, silicon carbide. Here, such covalent network crystals are very hard. These are all what? Very hard. And high melting point. And also they are usually pure thermal and electrical conductors. Pure thermal and electrical conductors. Okay, these are about the covalent crystals, otherwise called covalent solid. Here, the covalent solid, their constituent means atoms. These atoms are bound together in three-dimensional space, a three-dimensional network. Three-dimensional network ended by covalent bond. Here, what are the examples? Here, the examples are diamond and also silicon carbide. Here, the such covalent network crystals here, they are, what are the characteristics of covalent solid means? These covalent crystals are hard, very hard. And also, they have high melting point. High melting point. They are usually poor thermal and electrical conductors. Okay, these are all what? Covalent crystals. Next about the molecular crystals. What are about the molecular crystals? Here, these constituents are neutral molecules. About the molecular crystals. Constituents are neutral molecules. What is about the neutral molecules? They have no charge. Okay. And they are held together by weak van der Waals force. Okay, weak van der Waals force. Okay, here these constituents are neutral molecules. They are held together by weak van der Waals force. Here molecular crystals are, molecular solids are soft. The previously learned that the molecular solids are soft. They do not conduct electricity. Do not conduct electricity. Here the molecular crystals are again classified into three types. One is about the non-polar molecular solid. And about the polar molecular solid. Here the hydrogen bonded molecular solid. Okay. Here the molecular crystals are classified. What are they? Three types. What are they? Non-polar molecular solid, polar molecular solid, and also hydrogen bonded molecular solid. What is about the non-polar molecular solid? Non-polar molecular solid. Here they are held together by weak dispersion force or London force. First one, non-polar molecular solid. Here what is that one? Here the constituent, the molecules are held together by weak dispersion force, otherwise called London force. Okay, can you understand? Here, what is about the non-polar molecular solid? The non-polar molecular solid, the constituent molecules are held by weak dispersion force, otherwise called London force. Here, they have low melting point. Important point, low melting point. Okay. They are usually in liquid or gaseous state at room temperature. The liquid, gaseous, gaseous states at room temperature. Can you say what are the examples of molecular solid? What are the examples? Already we learned that one. This of naphthalene, anthracene, glucose are the examples of what? Here the molecular solid. Okay, that is what? Non-polar molecular solid. Can you say about the polar molecular solid? What are about the polar molecular solid? The polar molecular solid, they are held together by strong dipole-dipole interaction. Okay, polar molecular. Okay. They are held together by strong dipole interaction. Okay. Here they are held together by relatively strong dipole interaction for polar molecular solid. They have high melting point, high melting point. Example, what are the examples? Examples are carbon dioxide, solid carbon dioxide, solid NH3. What is NH3? Ammonia. Solid NH3. Okay. Can you say about the few points about the polar molecular solid? Here the polar molecular solid, these are the constituent of molecules formed by the polar covalent bond. That is the definition. These are the constituent of molecules formed by the polar covalent bond. Here what is the bond? Here what is the force? Here means there are relatively strong dipole interaction, and about the melting point is very high, and about there, what are the examples? Solid carbon dioxide and also solid ammonia. Okay. Here, next one is about the hydrogen bonded molecular solid. Hydrogen bonded molecular solid. Here, the constituents are held together by hydrogen bond. Here, the atoms or molecules or ion are held together by which bond? Hydrogen bond. They are soft. They are usually soft. And also they are soft under room temperature. Okay, that's the meaning. But the example means solid water molecules. glucose, urea. Okay, these are all the examples of hydrogen bonded molecular solid. Next about the metallic solid. What is about the metallic solid? Here the metallic solids, the lactic points are occupied by positive metal ion. The lactic points are occupied by positive metal ion. Positive metal ion. Here, and the cloud of electrons are pervades the space. That means the cloud of electrons are spread the space. The electrons are spreading the space. And that about they are very hard. These metallic crystals are very hard. Okay. High melting point. And they possess an excellent electrical and thermal conductance. Electrical and thermal conductance. And about the metallic solid. This metallic solid, the lactic points are occupied by metallic ions. Okay, here means the lactic points are occupied by positive metal ions, and the cloud of electrons are spread over the space. Anyhow, the metallic solid have excellent electrical and thermal conductance, and also they are very hot, and they have high melting and boiling point. Okay, melting point. Okay, next about. One of the important 2 mark question. What is crystal lattice and about what are unit cell? One of the 2 mark question. Crystal lattice. Unit cell. What is about the crystal lattice means here? The atoms or ions or molecules related to one another in a 3-dimensional pattern. The regular arrangement of these species, maybe atoms or molecules or ions, this species, throughout the crystal is called crystal lattice. The regular arrangement, it has some regular arrangement. The regular arrangement of these species throughout the crystal is called crystal lattice. About the unit cell is very, very important about the unit cell. What is about the unit cell means? The fundamental repeating structural unit of the crystalline solid. That means the basic repeating structural units of the crystal solid is called unit cell. What's the definition for unit cell? The basic repeating structural unit. The basic repeating structural unit of the crystalline solid is called what? Unit cell. Okay? And about what is about the primitive and non-primitive unit cell? That's a very important question. Primitive and non-primitive. Primitive and non-primitive. What is about the primitive means? A unit cell that contains only one lattice point. Don't forget that only one lattice point. That means the one of the unit cell that containing only one lattice points are called as what? Primitive unit cell. What is about the non-primitive unit cell means? There are additional lattice points. Additional. Additional lattice points in either the face of the unit cell or within the unit cell. What is about the face? Did you know about the face? For example, this is one of the unit cell. Okay, one of the unit cell. Okay, this unit cell, how much phase can you say? How much phase? This side is first phase, second phase, third phase, fourth phase, fifth phase, and back side, sixth phase. Am I right? So here about the primitive and non-primitive. What is about the non-primitive? I told you that the non-primitive means this is a crystal lattice. Here, additional one of the lattice points, either the phase means any one of either the phase or within the unit cell, that are called what? Non-primitive unit cell. Okay? But the primitive unit cell, we have only what? Only one lattice points are called primitive. Okay? Here there are 7 primitive crystal systems. There are 7 primitive crystal systems. There are 7 primitive crystal system. Okay? That means the unit cell is characterized by 3 edge length. The unit cell is characterized by 3 edge length. Okay? This is one of the unit cell. Okay? Unit cell. Here, the lattice constant A and B and C. Okay, this is a point. We are saying A. This is B. This is C. A, B, and C. And having the angle between the edges. The angle between the edges are. This is the angle of what that one? Angle is gamma, alpha. This is then beta. This is what? Gamma. Okay, these are the 3 angles. We have to draw a 7 primitive crystal cubic. 7 primitive crystal. One is cubic. Second one is a rhombohedral. Third one is a hexagonal. Fourth one is a tetragonal. Fifth one is a orthorhombic. The sixth one is a monoclinic. And the seventh one is a triclinic. These are the 7 primitive crystal systems. What are they? Can you remember? Cubic, rhombohedral, hexagonal, tetragonal, orthorhombic, monoclinic, and triclinic. Okay. These are the 7. Bravis defined 14 possible crystal systems. Okay. There are 14 possible crystal systems. Let us see, can we draw one by one? The cubic system of first one is the cubic. First one is what? Cubic. First you have to draw cubic. Okay, here A, B, C. Okay, A, B, C. A, B, C. A is equal to B B is equal to C. That means the first one is what? This is an alpha, beta and gamma. Okay, so alpha is equal to beta is equal to gamma. So we can say 90 degree. Alpha is equal to beta, beta is equal to gamma. So we can say what? 90 degree. Next about rhombohedral. How to draw the rhombohedral? A little variation may be happen, so we should be try it. Okay, take one. Let and practice. Rhombohedral. Okay, first one is A, B is C. Okay, here A is equal to B is equal to C. That means A means alpha is equal to beta is equal to gamma, but it is not equal to 90 degree. Don't forget that rhombohedral is not equal to 90 degree. Okay. Next about the hexagonal. Hexagonal. A, B, C. Okay? A, B, C. Hexagon. Here, A is equal to B, but B is not equal to C. A is equal to B, B is not equal to C. So, A alpha. Alpha is equal to beta, that is what? 90 degree. But C, in the case of C, gamma. Gamma is equal to 120 degree. Gamma is how much? 120 degree. Okay. Next about tetragonal. This also almost the same like that. Tetragonal. Here A, B, C. A, B, C. Okay. Here A is equal to B is not equal to C. A is equal to B, B is not equal to C. Okay. So alpha is equal to beta is equal to gamma, but it is what? 90 degree. It is what? 90 degree. Okay. Next about orthorhombic. Here orthorhombic, A is not equal to B, B is not equal to C. Orthorhombic, A is not equal to B, B is not equal to C. Like that monoclinic also same way. A is not equal to B, B is not equal to C. And triclinic also same like that. A is not equal to B, B is not equal to C. The both three are is not equal to B, A is not equal to B, B is not equal to C. Orthorhombic. A, B, C. Here A is not equal to B, is not equal to C. Alpha is equal to beta is equal to gamma, but it is what? 90 degree. 90 degree. Next about the monoclinic. The monoclinic, A is not equal to B, B is not equal to C. Okay. The monoclinic. Monoclinic. A, B, C. Here A is not equal to B, B is not equal to C. Here alpha is equal to gamma, which is equal to 90 degree, and beta is not equal to 90 degree. Don't forget that alpha is equal to gamma, which is equal to 90 degree, but beta is not 90 degree. Okay. Next about the important one is triclinic. Triclinic is one of the important question. Triclinic. Okay, here A, B, C. Okay, A is not equal to B, B is not equal to C, but alpha is not equal to beta, beta is not equal to gamma, but it is what? 90 degree. Okay, anyhow, these are the simple question may be asked in the form of one word question. And about try to take return practice the Brevis lactics. I think that the page number is 182. Okay, page number is 182. You should be write the assignment. You should be draw the all the structure. This is important. Okay, page number page 182. The assignment. Draw the structure. Draw this structure. Structure of Brevis. Okay, the page number 182. They are having cubic, tetragonal, hexagonal, orthorhombic, monoclinic, trigonal, and triclinic. These are examples. Please draw this Brevis lattice, page number 82. This is your assignment. Thank you all of you. Thank you. Have a nice day.